Since solving systems of equations by graphing has its downfalls because you have to make sure your lines are drawn really straight, and you have to make sure that your solutions are integers or whole numbers, then there are other ways of solving nonlinear systems as well. We're going to be looking at solving systems of equations with quadratic equations in them as well as linear. So let's take a look at the system of equations. This system of equations has one linear equation and one quadratic equation. So if we're looking at this, I first need to make them into one equation, and this I would use the substitution method. So I would substitute the value of y, which is 2x plus 1 in the first equation, for y is in the second equation. So I would have 2x plus 1 equals x squared plus 1. Now remember, when we solve a quadratic equation, it has to be set equal to 0. So I want to set this whole thing equal to 0. So that means I need to move everything to one side. So I'm going to subtract 2x from both sides. They cancel out. I'm left with 1 equals x squared minus 2x plus 1. And then I'm going to subtract 1 from both sides. That's 0, which is what we want. And then I have x squared minus 2x. And then I don't have a value there because it's 1 plus 1 is 0. So the next thing I want to do then is to solve the quadratic. Usually in this case I recommend solving the quadratic by factor. So if I'm going to look at factoring this, I only option for here is whether you have binomials, you have either perfect squares or you have a common factor. So in this case I have a common factor. So I can pull out my common factor. So I would have 0 equals, my common factor is x. So x from x squared is x. And then x from 2x is minus 2. So I have then to take each one of my factors and set it equal to 0. So I have either x being equal to 0 or x minus 2 being equal to 0. X is equal to 0 is already solved for x, so to solve the other one, x minus 2 equals 0, I would have to add 2 to both sides. Minus 2 plus 2 makes 0, they cancel each other out, I'm left with x, and then 0 plus 2 is 2. So x is either 0 or x is 2. Now I have to decide which equation I want to work with. Usually I choose the linear one because it's easier than with the exponents. So if I'm using the linear, I have y equals 2x plus 1. And every time there's an x in there, I have to substitute it with my values that we just came up with. So I would have y equals 2 times 0 plus 1 and y equals 2 times 2 plus 1. According to the order of operations, I would do the multiplication first. So I would have y equals 2 times 0, which is 0, plus 1. And then I would also have y equals 2 times 2, which is 4, plus 1. So if I'm adding now, I would have y equals 1 and y equals 5. So my two solutions then for my equations are 0, 1, and 2, 5. Let's take a look at another example. So again, on this one, I have a quadratic equation, y equals x squared plus 4, and a linear equation, y equals 4x. I want to use the substitution method to start off, so I'm substituting y with x squared plus 4. So I have x squared plus 4 is equal to 4x. I want to set this equal to 0, so I have to subtract 4x from both sides. So then on the left, I would have x squared minus 4x plus 4 is equal to 0. I now want to solve the quadratic equation, and I want to solve it by factoring. So I'm looking for two numbers that multiply together to give me 4, but have to add together to give me 4, and that's 2, right? Because my choices are 1 and 4, or 2 and 2, and 2 and 2 add to make 4. So this tells me that my signs are the same. This tells me that they're both minus. So I would have x minus 2 squared and that would be equal to 0. So I would then have to take the square root of both sides. So I'd have the square root of x minus 2 squared and the square root of 0. So the square root and the square cancel each other out, so I have x minus 2, and then that equals 0. So to solve this one, I would have to then add 2 to both sides, and I'd be left with x because these two would cancel out, and x would be equal to 2. I then want to pick the easier equation, which usually is a linear, so I'm using y equals 4x, and every time there's an x, I'm substituting it in with a 2, so I have y equals 4 times 2, so y is equal to 8. So that means my solution then is 8. Let's take a look at, so I want to take a look at one more example, this time them both having quadratic equations. So again, I want to use the substitution method to substitute negative x squared plus 4 in the second equation where the y value is. So I have negative x squared plus 4 being equal to x squared minus 4. So I want this to be set equal to 0. So I want to get rid of the things on one side so it's equal to 0. So I add x squared to both sides. Minus x squared plus x squared cancel each other out. I'm left with 4. And then x squared plus x squared is 2x squared. And then I still have the minus 4. Then I need to get rid of this 4, so I need to subtract 4 from both sides. So 4 minus 4 cancel each other out and be left with 0. And then I would have 2x squared minus 8. So now I would look at solving this equation by factoring. So I want to move my screen up a little bit and I can factor. So if I'm going to factor, I'm looking for two numbers that multiply together to give me negative 8, but we don't have anything to add in front, so we can't really do that. So we have to look at a common factor. So my common factor of 2x squared and negative 8 would be 2. And I would still have it equal to 0. So if I pull out my common factor of 2 out of 2x squared, I would have x squared left, and if I pull 2 out of negative 8, I would have negative 4. So then I can still factor this part that's left on the inside. So I'd have 0 equals 2 times, and that's a difference of squares, so I take the square root of both terms, which is x plus 2 and x minus 2. And then I would have to set all of these things being equal to 0. So 2 wouldn't make sense to say 2 equals 0 because it can't. So that really is kind of a null and void aspect. So then I'm just looking at x plus 2 being equal to 0 and x minus 2 being equal to 0. For the plus 2, I would subtract 2 from both sides, and I'd be left with x being equal to negative 2. For the minus 2, I would add 2 to both sides. So the 2's again would cancel each other out, and I'd be left with x being equal to positive 2. So x is equal to negative and positive 2. Now I have to pick one of my original equations to substitute the value in for x so I can find y. So I'm going to pick y equals x squared minus 4. So if I go ahead and substitute my values of x in here, I would have y equals negative 2 squared minus 4 and y equals 2 squared minus 4. Both times we would do the exponents before the subtraction first, so I'd be left with y equals 4 minus 4 and y equals 4 minus 4. So y would be equal to 0 both times. So my solutions then would be negative 2, 0, and 2, 0.